Look up at the night sky. On a clear evening, you might see a bright star-like object. That's Jupiter, the largest planet in our solar system. Jupiter is a gas giant, a massive world of swirling clouds and powerful storms. It's a planet of extremes, with a gravitational pull so strong it influences the entire solar system. Jupiter has captivated humanity for centuries. Ancient civilizations tracked its movements across the sky, weaving it into their myths and legends. Jupiter's size is truly awe-inspiring. It dwarfs all other planets in our solar system combined. To put it into perspective, imagine Earth as a grape. On this scale, Jupiter would be the size of a basketball. Jupiter's diameter is a staggering 86,881 miles, or 139,822 kilometers, over 11 times that of Earth. Its volume is so vast that you could fit over 1,300 Earths inside it. Unlike Earth, Jupiter doesn't have a solid surface. It's a gas giant, composed primarily of hydrogen and helium, the two most abundant elements in the universe. These gases exist in various states within Jupiter's atmosphere, creating a complex and dynamic environment. Deep within Jupiter's atmosphere, the pressure and temperature increase dramatically. The hydrogen gas transitions into a liquid metallic state, forming a vast electrically conductive ocean. This metallic hydrogen is thought to be responsible for Jupiter's incredibly powerful magnetic field. While Jupiter is primarily a gas giant, scientists believe it may have a relatively small, dense core. Jupiter's atmosphere is a mesmerizing spectacle of swirling clouds, raging storms, and vibrant colors. Bands of white, orange, brown, and red clouds, driven by powerful jet streams, circle the planet at different latitudes, creating a breathtaking tapestry of ever-changing patterns. The colors we see in Jupiter's atmosphere are the result of complex chemical reactions and atmospheric circulation. The white clouds are composed of ammonia ice, while the reddish-brown hues are likely due to the presence of phosphorus, sulfur, and hydrocarbons. Jupiter's atmosphere is incredibly turbulent. Storms rage across its surface, some larger than Earth itself. These storms are driven by heat from Jupiter's interior and the planet's rapid rotation. For over 300 years, astronomers have observed a colossal storm raging on Jupiter's surface. This storm, known as the Great Red Spot, is a swirling vortex of reddish clouds larger than Earth itself. It's a testament to the extreme weather conditions on this giant planet. The Great Red Spot is a high-pressure storm with winds swirling counterclockwise at speeds of up to 400 miles per hour or 640 kilometers per hour. Its oval shape is constantly changing, expanding and contracting over time. Observations suggest that the Great Red Spot has been shrinking in recent decades, but it remains a prominent feature of Jupiter's atmosphere. The reddish color of the Great Red Spot is thought to be due to the presence of complex organic molecules. Jupiter reigns over a miniature solar system with over 79 known moons orbiting this gas giant. These moons vary dramatically in size, composition, and history. Some are captured asteroids, while others likely formed alongside Jupiter in the early solar system. Among Jupiter's many moons, 4 stand out: Io, Europa, Ganymede, and Callisto. These 4 moons, known as the Galilean moons after their discoverer Galileo Galilei, are large enough to be considered planets in their own right. They are worlds unto themselves, each with unique features and potential for harboring life. Io, the innermost of the Galilean moons, is a volcanic world, its surface scarred by erupting volcanoes and lava flows. Io, the innermost of the Galilean moons, is a world of fire and ice. It's the most volcanically active body in our solar system, its surface constantly reshaped by powerful eruptions and flowing lava. Io's volcanoes erupt with such force that their plumes can reach hundreds of kilometers high, spewing sulfur and other materials into space. The intense volcanic activity on Io is driven by tidal heating. Jupiter's immense gravity and the gravitational interactions with the other Galilean moons create tremendous tidal forces within Io. These tidal forces squeeze and stretch Io's interior, generating heat that melts rock and fuels the moon's volcanic activity. Io's surface is a riot of color, a testament to its volcanic nature. Beyond Io, the three outer Galilean moons, Europa, Ganymede and Callisto, offer tantalizing possibilities for harboring life. These moons, orbiting the gas giant Jupiter, are some of the most intriguing objects in our solar system. These moons are thought to possess vast subsurface oceans of liquid water, potentially containing more water than all the oceans on Earth combined. The presence of liquid water is a key ingredient for life as we know it, making these moons prime targets for future exploration. Europa, with its smooth, icy surface, is a prime candidate for life. Its surface is crisscrossed with cracks and ridges, hinting at the dynamic processes occurring beneath. Beneath its icy shell, scientists believe a global ocean of liquid water exists, warmed by tidal heating from Jupiter and the gravitational interactions with the other Galilean moons. This tidal heating could create the energy needed to support life. This ocean, potentially tens of kilometers deep, could provide a stable environment for life to emerge and evolve, shielded from the harsh radiation of space. The thick ice crust acts as a protective barrier, creating a haven for potential microbial life. Ganymede, the largest moon in the solar system, also shows evidence of a subsurface ocean. Its immense size and unique characteristics make it another fascinating subject for study. Its ocean is thought to be sandwiched between layers of ice, potentially containing more water than Europa's. The complex layering of ice and water on Ganymede presents a unique environment that could harbour life in ways we have yet to understand. Jupiter possesses the strongest magnetic field of any planet in our solar system, a force of nature that is both awe-inspiring and immensely powerful. This magnetic field is so powerful that it extends millions of kilometers into space, forming a vast magnetic bubble known as the magnetosphere, which dwarfs the planet itself. The source of this immense magnetic field lies deep within Jupiter. It is generated by the rapid rotation of its metallic hydrogen core, a unique feature among the planets in our solar system. This electrically conductive fluid creates a dynamo effect, similar to the process that generates Earth's magnetic field, but on a much grander scale. However, Jupiter's magnetic field is far more powerful, over 20,000 times stronger than Earth's, making it a dominant force in the solar system. Jupiter's magnetosphere acts as an invisible shield, protecting the planet from the constant bombardment of charged particles from the Sun, known as the solar wind, which can be incredibly destructive. These particles are deflected around the planet, preventing them from stripping away its atmosphere and causing significant damage. The interaction between Jupiter's magnetic field and the solar wind creates spectacular auroras at the planet's poles, lighting up the Jovian skies with brilliant displays of color. These auroras are similar to the northern and southern lights on Earth, but they are much more intense and widespread, a testament to the power of Jupiter's magnetic field. For centuries, astronomers have studied Jupiter from afar, using telescopes to observe its ever-changing atmosphere, marveling at its swirling clouds and dynamic weather patterns. They meticulously tracked the movements of its moons, which dance around the planet in a celestial ballet. However, it was the dawn of the space age that revolutionized our understanding of this gas giant, opening new frontiers in space exploration. In the 1970s, NASA's Pioneer and Voyager spacecraft provided the first close-up views of Jupiter, revealing its swirling clouds, massive storms, and faint ring system in unprecedented detail. These missions were groundbreaking, offering humanity its first intimate glimpse of Jupiter's complex atmosphere. These missions also discovered Jupiter's faint rings and the active volcanoes on Io, which were a surprising find, showcasing the dynamic nature of Jupiter's moons. They also found evidence of a possible ocean beneath the icy surface of Europa, sparking curiosity about the potential for life beyond Earth. In the 1990s, NASA's Galileo spacecraft spent 8 years orbiting Jupiter, providing detailed observations of its atmosphere, magnetosphere and moons. Galileo's mission was pivotal, as it offered a wealth of data that deepened our understanding of Jupiter's complex system. Galileo also dropped a probe into Jupiter's atmosphere, providing the first direct measurements of its composition and structure, which were crucial for understanding the planet's formation and evolution. In 2016, NASA's Juno spacecraft arrived at Jupiter, embarking on a mission to study its interior structure, magnetic field, and auroras in unprecedented detail. Juno's mission continues to unveil the mysteries of Jupiter, offering insights that could reshape our understanding of the solar system's largest planet.